Section 6.7, Graphs of Inequalities. So let's recall from what we did, probably in chapter 2, I think, the standard form for linear inequalities in the variables x and y. So we say that, well, a inequality will be in standard one of the following forms. Basically, we've either solved for y, if we can solve for y. If we can't solve for y, we solve for x, and the y will be on the left-hand side of your inequality, or if you can't solve for y, the x will be on the left-hand side of your inequality. So it's in the form y is less than or equal to, less than, greater than or equal to, or greater than mx plus b. Or if you can't solve for y, it's in the form x is less than or equal to, less than, greater than or equal to, or greater than some constant b. Now, just like with linear inequalities, with linear systems of linear equations, if you happen to have more than one equation, then a system of equations, we're assuming that we're doing an intersection between the solutions. So we're assuming an and. Similarly with linear inequalities, if we don't say anything and we just list a whole bunch of them, we're assuming the intersection between the solutions. So we're assuming an and. Okay, so let's do some examples. First off, let's just graph this inequality. 4x minus 3y greater than 0. I want to put this into standard form. So I want to write in standard form. So in this case, I want to solve this inequality for y, and I want y to be on the left-hand side of my inequality. So subtract 4x from both sides of my inequality. So negative 3y is greater than negative 4x plus 6. Then divide both sides of my equality by a negative number. Negative number, I'm going to switch the inequality around. So this is y is going to be less than, since I'm dividing by a negative 4/3 positive. So this will be a positive 4/3 x. 6 divided by negative 3 is a negative 2. So first thing to note here is that if we're less than, then it's true below. And let's actually give a little bit more room here. Okay. Okay, so let's see, this is y. It's going to be, let's say, less than, and say greater than. Okay. So if it is less than is true below, greater than true above. If it is an x, well, there's no above or below, but there is right and left. So it's true to the left. True to the left. And this will be true to the right. and this will be true to the right. And, well, if there's an equal sign, then this will be, you'll do this with a solid line. So the boundary line will be solid. Whereas if there's a no equal sign, then the boundary line will be dashed. Oops. There. So the boundary line would be dashed. Okay. So now let's do this. So this is less than, so this is going to be true below. And this is there's no equal sign, so the line. The slope of the boundary line is 4/3. So that's my rise and my run. And my, oops, y-intercept is -2. So let's draw this. So my y-intercept is -2. Draw some tick marks. Okay, so my y-intercept is -2, and I have a rise of 4 and a run of 3. So you go over 1, 2, 3, 1, 2, 3, 4. And it's a dash line. So let's do a dash line here. Okay. Now it's true below. So let's fill in below. So it's true here below. So this will be my answer. So this is my solution. Okay. It is best to write the fact that what you've highlighted is a solution, because sometimes you will shade where it's not true. Okay, so now let's do problem number 26. So in this case, system of equations. So I want to graph the solution set of each system. Okay, so let's do that. So first off, for y less than 3x plus 2. So this is already in standard form, each of these. I have that this is going to be true below. And this will be a dashed line. The slope is going to be 3. So it's a rise of 1, and the y-intercept is 2. For the other equation, I have that for the other inequality, I have that y is less than negative 2x plus 3. And so it's also true below. And this will also be a dashed line. The boundary line will be dashed. So a dashed boundary line. The slope will be negative 2. So rise of negative 2 and a run of 1. And the y-intercept is 3. Maybe I should say this is the second, and this is the first one. Okay, so let's draw this. Let's sketch the graph. X, Y. So on the first one, the y-intercept was 2. Well, let's put some tick marks before I do anything. Okay, so the y-intercept was 2, and the slope was 3. So you go over 1, up 3, 1, 2, 3. And it was a dashed line. They're both dashed lines. So let's sketch this. And it was true below, so it's true in this region. I'll put little arrows to indicate the direction where it's true. Next, for the second line, I have a y-intercept of 3 and a slope of negative 2. So you go over 1, down 2. And again, it's a dashed line. So it looks something like this. And it's also true below. So it's true in this region. So I'll just put little arrows to indicate where it's true. So now I see that the arrows both point in this direction. And so the overlap is this region here. So let me try, if I can, to fill this in. As best I can. It's not very easy to fill it in with this. And so my solution is this region here. Okay. Let me do problem number 34. So in this case, I have y is less than or equal to negative x squared plus 4. So this is actually the boundary line is a parabola. So the boundary line is a parabola. Well, maybe I'll say it. Boundary line is a parabola. And well, this will be a solid line. The boundary line will be solid. And we can see that this parabola is pointing down. So if I look at the boundary line, then this is this has a vertex at 0, 4, and it is pointing down since a here is equal to 1, which is less than 0. It means that this is a downward pointing parabola. And it actually has the same shape as the graph of y equaling x squared, since a here is just equal to a -1. So it has the same shape as the graph of y equal x squared. Okay. It's actually going to be true, well, within it, but well, we'll see. Next, let's look at y greater than -x plus 1. So this is going to be true above, and this will be a dashed line, dashed boundary line. The slope here is -1, and the y-intercept is 1. Okay, so let's do that. Let's draw the graph here. So 1, 2. Just put tick marks. Okay. So this was y equal -x squared plus 4. Oops. Okay. Y equal -x plus 4. So 1, 2, 3, 4. And so it should look something like something like that. It's not very symmetric, but it should be. Next, notice that, let me just check where this is true. And so if I want to check at the origin, I have that 0 is less than or equal to, well, I guess that's a question, is 0, y, less than or equal to -0 squared plus 4. Well, is 0 less than or equal to 4? Yes. So that means that this is true in this region where it's pointing towards the origin. So it's true at the origin. Okay. Next, let's draw the line. Oh, wait 1 second. I'm sorry about that. That was a solid line. For this one, it was a solid line. Yes. Okay, so this was an error. This was a solid line here. Okay. So this was a solid boundary line. Next, let's look at y-intercept is 1 and the slope is -1. So it looks something like this. This was the one that was dashed. And it's true above. So it's true in this region. Okay, so the overlap is just here. Here. This is my overlap here. Okay. And so here's my solution. So this region inside here is my solution. Okay, so that really finishes off